Hello, everyone.
Hello.
Hello, Dennis.
Hello, Adrian.
Hello.
Hello to our live viewers.
Today we have another topic. So I think we have never spoken so far dedicated about the cloud in any form. Have we?
I think we touched upon it, but we never really had a main title on it and sort of dedicate. We spoke about cloud-oriented DevOps and orchestration and sort of cloud automation tools, but never really about the strategic aspect of being cloud native and what it really means and how cloud native differs depending on the size of the business.
What is actually the difference between cloud to cloud native and native cloud? So this is already an interesting topic by itself, I think. And why is it so relevant for us? And why is it actually hard to hide from anything which is cloud native? So which is the main topic today, which is cloud native, right? And today we have several conferences running at the same time. We have the Cloud Fest, which is right 100 meters away from my office. And I was there until this morning already. So yesterday as well. And we have at the very same time in Paris, I think, it's the KubeCon and the Cloud Native Conference. So it's a very conference heavy thing. There are some other conferences actually as well, but we needed to decide for one. And since we don't have too much time this week, we decided to just go traditionally for the CloudFest one. But I had already the feeling that cloud native wasn't a big topic there because probably because the cloud native conference was somewhere else. Anyway, so far, Thomas already asked for. Where is it? Oh, I'm on the wrong screen. Ask for how was the CloudFest? The CloudFest still is, so it is until tomorrow, and it is, as always, it's a great thing. It is you go there, it's another world, so it's more unique than any other conference I ever was. Because it is so nicely integrated into a amusement park. If you would take that away, it would be just a normal conference like the Cloud Expo, for example, in Frankfurt, which would very similar. Then you would have then basically an exhibition, right, where everyone, especially the vendors, are and selling their stuff, where you can talk to them. This is one of the, at least for me, one of the most interesting parts to go to a conference. As CTO, as client, as someone who's looking for partners or for new solutions, I like to talk with others about things. I like to challenge people. I like to go to a booth and ask them for what is your product. So actually, when it comes to the context of small to medium-sized business, why should a small company or startup coming to you, right, and buying your product? And it is often a little bit like many of the people there are more salesmen than they are actually technical people. And I really have to say that this is not about any specific conference. This is very often that people are, let's say, salespersons and not too much, let's say, convincing for people like me who really looking for something very specific. And this is what I'm still looking for. And there are people like, we have a good relationship with Mugenius. They offering some PaaS service for Kubernetes. And this is a really great solution. And I really would really love to talk with them. Great people. So I recommend them. So we are actually clients there. This is something great. So where you have really, let's say, fruitful discussions about the actual matter, which brings you forward, which is feedback in the same moment for the actual vendor, and it's a win-win-win situation for everyone. What I don't like too much is when you go to a very traditional cloud, let's say cloud vendor can say, and they try to sell you virtual service and tell you that's actually better to do that yourself than, taking some managed services, and you can't really have a discussion about total cost of ownership. That's actually one of those, this is awkward in some ways. It is not real, so people ignore reality in that case. This is what I don't like too much. So I'm looking still for the people where I can have very good discussions. And then probably I'm used to LinkedIn, where you have actually quite a lot of competency in the feed. So people are very specific on the topic, and LinkedIn does help to find the right people for you. And when you go to a conference, it is more traditionally mixed. And people are not on the same level. They're not even on the same, let's say, we talk a lot about continuous deployment, continuous delivery, TDD, and those kinds of things. And if you want to combine that on a cloud conference, it becomes hard. They don't really know what you're talking about. And it's a little bit like, let's say continuous delivery for them is a pipeline. It's
also
a little
different audience. It's more executives, more COOs, less so VPs, right? So it's more
exactly.
up and to the right on the vertical in businesses. So more on the operational side.
Very operational. It is very operational. So they are looking actually for, when we say we try to avoid operational personnel, so to have instead focus on development and value, this is the opposite. So they're doing the exact opposite, right? And probably, if you want to have that, you better go to KubeCon, where it is all about how to manage the Kubernetes in a way that developers can use it. So this
how
is
to
then
automate the management rather than cost optimize it.
exactly. So and it is relevant. So it is not wrong, but it is actually for something different than I am actually about as a person. So yeah, this is just wanted to say. So it's not bad. Last year it was not every conference was at the same day. So you had both vendor types there, and this was a little bit missing this year. So yeah, it was okay. So my team was yesterday here as well. So we had a good time. It was funny. It's cool, yeah, but I'm back to work right now. So this is, but I can talk a little bit during the session about when I get to something. But especially today, I think we should talk about the actual aspects of cloud native, why we should use it, and with a context. So I like to talk about the context of small to medium-sized businesses or startups. So where you really need to focus on development, where you need to focus on the creation of value and need to have everything as managed as possible, with the total cost of ownership in mind. And the very basic example, when we now have a transition from traditional cloud to cloud native, which is on a traditional cloud, cloud does have some form of definition as well. It is, let's say, there are, many definitions out there, but the one I like most is that you say cloud is something where you can self-service your computing power. So this is a very simple thing. So you need to have some computing power. In the past, it was virtual server, something like that. You log in, you do some provisioning, and you get that. So this is actually how it started 10 to 15 years ago to become something where everyone said you need to go to cloud.
And you have access to the platform that does that without interacting with a human on the service provider.
Yeah, this is what I mean by self-service. You can do that by yourself in the moment you need that, and you can cut it off in the moment you don't need it anymore, which is the difference between just the hosters we know from the past, where you rent a virtual machine for 2 years and you need to basically quit that on some point in order to get away from that.
I mean, when I started off in tech, our even self-hosted internal product work or agency style work, everything was hosted on one of two things: a rented hosting solution, where you went to somebody and said, I'm going to host a website, I need a domain name and FTP access and SSH access, and I need basically a box that needs to be exposed to the internet, and then I will put stuff around it and inside it. Or I need a rack, or I need a slot and a BGP connection and fiber, and I will come in and install my hardware. And then I will run everything on that through either Linux kernel virtualization or just by having a sysadmin, and then basically they set up an internal, what you would now consider sort of a native or internal cloud or intranet solution.
Yeah.
That will then be partially publicly exposed to the internet. So that's where I started. Sort of that's where this all came from. And that's nowadays you would consider all of that self-hosting. And cloud solutions are generally one layer of abstraction above that, where the baseline is you come in, you buy credits, and you are literally being sold compute as a digital currency rather than servers. There is no talk about servers. You create whatever container you need, whether the container actually ends up serving anything, or whether it's just doing compute, whether it's calculating something, or just holding data. Like in the case of, let's say, more specialized tools like edge functions or S3, like having bucket storage. So it quickly differentiates into this: we're selling you storage as service, traffic as service, compute as service, or some combination of it. Or locality, right? You can also sell compute locality, with edge functions and serverless functions, where you can tell somebody, hey, I need compute in Central Africa, and I already have a server, but I need some part of it to be offloaded, and I need my internal network to sort of expand to that region. So what's the difference? Cloud native, native cloud.
So maybe we should start with
some comments on it already.
Yeah, we actually have some. I think we should not talk too much about native cloud, because native cloud for me is some very biased, opinionated, vendor-driven terminology. Some people tend to use, especially in the serverless space, and I don't like it very much, because there is no definition for native cloud, because it is, if you go to AWS, there's another definition for native cloud than it is at DigitalOcean or somewhere else.
Yep.
And cloud native is the more agnostic principle. Like let's quickly start. So for me, let's say the cloud native aspect is that you actually build something with the cloud in mind and you run it in the cloud. Native cloud is more like you build it basically entirely inside the cloud and use it there. So this is a slight but different. It is more by talking about serverless function versus Docker. So this is very simple for everyone to understand, even though it is not very precise. But some people even argue that Docker is not part of cloud native. No, it is true. Docker wasn't invented for being cloud native, but Docker is, or containerization in general, is a very fundamental part of cloud native. So there is not much in cloud native space which is not running in containers. And the native cloud aspect is something where you actually, for example, serverless function, you don't have really something on your computer. You have some source code there, but it's basically, you hit basically a change, and you can only build that online. It is basically built in the cloud. There are ways to do that on your computer in some way as well with simulations, but this is where it becomes awful to develop in. And it is always bound to some form of provider, which means that serverless, for example, is a different thing in DigitalOcean than it is in AWS. And it is not really portable. So there is some solution where you can port something from for example, Azure to AWS.
But the devil's in the details, and you will adapt to the details. And if you change the cloud provider, the details will change. So your code will have to change.
Yeah, it is very biased.
Even if there isn't a compilation problem, there is an infrastructure bias.
Yeah, and you have some form of biasness as well, or opinionation with let's say cloud native and orchestration with containers, but it's predictable. You can still call it in the quality of agnosticism, which means that, for example, let's take, we said in a small area. So you have, for example, an application with 5 services in the front end. And a database like a Postgres database and a Redis server as caching server. For example, very simple web application these days. You take that you can containerize that entirely if you like, but you could, for example, say I only want to have my business logic or my services containerized, and the rest is then in form of managed, like let's say, or not orchestrated, but I forgot that. But actually, we assemble that to one application, and you can then move that. You can basically develop that onto your system locally in your IDE, and then you have that in some form of CI/CD pipeline where you create the actual images and you move the images to wherever you want. You can move that onto AWS, EKS, ECS. You can create virtual service. You can move it to app platform of DigitalOcean. You can GCS, doesn't matter, everywhere where you actually be able to run those containers, you can run it. You can run it on Kubernetes, you can run it on Docker Swarm. It doesn't matter as long as you have a platform where you can run containers, which is very agnostic. Because so the variety of vendors you can use is actually is a big advantage in that moment.
When you say agnostic to what?
Agnostic to questions.
Like, agnostic to hardware, agnostic to cloud vendor, like
agnostic to cloud vendors. Actually, it is always in the context of being vendor locked in or agnostic. So this is actually what you need to think of when you plan your application.
From a CTO's perspective, how do you experience vendor lock-in? You specifically, you were a lot on DigitalOcean. I used primarily AWS. I was usually working in Y Combinator funded startups, so I was usually in AWS, very limited Azure exposure. So I'm all about AWS and GCP.
Actually,
delivery.
the most of the time I was working in data centers. So no, it was basically pre cloud native times, and then we moved to AWS, a little bit GCP, and then basically DigitalOcean. And the point was in AWS, there was not too much like vendor locked in. You always have a little bit, like especially when you go in, for example, into the access management, IAM or other systems. Then you have of course the problems is those
The
are the
IAM
parts you
has to
cannot
be-
really move, right?
The IAM has to be locked in because
Exactly.
that's your immovable parts that you don't.
Exactly, and all the governance in between. Of course, you can use something like Terraform, but then the providers are different. As well. So the point is that you have, let's say, forget a little bit about the actual platform you run on, but take as an interface in this case, take the, for example, a Docker setup, right? So you have your containers and you have other dependencies like databases in this example. The example I used was a Postgres, a database management system, and a Redis system. So those can be used locally, for example, inside Docker containers for development purposes. And you can basically use them with a cloud provider next to your containers, where you, for example, use traditional Kubernetes, let's say, in a cloud native, fully managed service environment, and you just attach external managed databases as well. So the very important aspect here is the managed aspect. So otherwise, if you would manage it yourself, it's not really cloud native anymore. And you could do multi-cloud as well, which means that, for example, I see that very often when people use Mongo databases, they use Mongo Atlas, for example, or use AWS databases like Aurora or something like that onto another cloud.
We have to mention in multi-cloud exists because the cloud vendors, their primary business strategy is it's free if you manage it yourself, and there's an enterprise license if we manage it for you with a rich interface, right? So that's Redis, that's Mongo Atlas, that's ClickHouse, that's all of the mostly databases, Kafka, Confluence. So when it comes to, let's say, managed services where the management side for you is about observability and auto-scaling, there's usually a split in that the tool is open source and can run on any cloud, and then the vendor itself runs their own cloud service. Generally, it comes in that form.
What is the own cloud service for you?
Well, Atlas that you mentioned is a good example. Confluence comes to my mind immediately when we're talking about. Sorry.
Confluence?
Confluent. Sorry, I got the typo. I made a typo. Confluent, for example, when it comes to managed Kafka clusters, and any back in the day, that's the only way you could really manage a large Cassandra cluster or MapReduce on Hadoop. Those you would generally want to either buy enterprise grade and sort of have a license for them, or have a server shipped, like a hardware. Just entire, not even a rack, but an entire half of a building shipped to you. From my perspective, the multi-cloud scenarios usually are an optimization of vendor locked-in practices, right? So you have a really good solution, a really good product that you don't want to set up yourself and sort of run under limited capacity, but you actually want to run it under the original cloud setup, and then integrate into your either native cloud native setup, or however you Terraform them, open up something so that you can use them, or use them as a separate system. For maybe you're doing MongoDB, you're doing Atlas for analytics and for business intelligence, but all the operational stuff might be in DynamoDB and on AWS. So you sort of have either some form of replication going over, or using it as cold storage for analytical purposes, or for debugging, right? So you might do it for observability or monitoring.
But let's don't be too much about multi-cloud, but because multi-cloud exactly also in the same moment like hybrid cloud is a very, let's say, advanced pattern in most companies I know in in the SMB or startup area don't use. So maybe let's say a connection of one, for example, where you have, let's say, one database in your containers or something like that. But it is more likely to end up seeing companies who have everything on AWS, everything on DigitalOcean, everything on GCP or something like that. Because for the standard applications, most public provider does, they provide everything, and in most cases you get credits anyway, right? This is the start of thing.
You would want them to provide everything, and they make it, and they do incentivize you, right? So until recently, you were heavily disincentivized from sharing data across different clouds because it had extreme egress costs, and it was basically unfathomable for a medium or small to medium business to pay transaction fees, bandwidth fees, basically, for moving their data and to creating a replica on another cloud.
Actually, so most cloud providers still have the problem that they charge too much in between their own services, in my opinion.
It is changing now. So Google AWS is like I think the most expensive one in that regard. I think I have a chart somewhere. I'll find the chart because I have one on this topic. But yeah, it is a common problem that most cloud providers appear to you as premium. They have free tiers for most of their useful, the container orchestration and some kind of databases, some kind of cache, some kind of message queue, some kind of telemetry, some kind of observability tool, some kind of CI/CD pipeline.
Yeah.
You get a freemium tier, and then you basically get incentivized to go slightly beyond that, and then start ranking in credits and go.
A good example, as you just said, that let's say services. When we come to caching, not caching, message queuing, for example, there is an agnostic way to do that, like things like how was it called, FAPS, I think, Redis, like BullMQ, where you could do something with Redis or just in containers, just in memory. So you could do that, and that's actually quite an interesting thing because it's still agnostic. Or follows the idea of agnosticism, because you can basically run that on let's say on every form of orchestrator. So orchestrators are basically everywhere. You could even run it not in cloud native. So this is another aspect which makes it even more interesting if you need to move into some form of private cloud or even non-cloud anymore. But if we now take a look at, if you go to AWS because you got credits, and you go to SQS, which is I think, simple queuing system, or I think it was the start. And we used that for quite a while as well, but I forgot the actual name of it. But it is basically a very simple form of queuing system, which is fully managed for you, but it's unique. So it doesn't follow any form of standard. If you use SQS, you use it, and only that.
Generally, you would come from a 0MQ sort of Rabbit compatible standard, and then want to go cloud native, and SQS is slightly away from that.
Exactly, but SQS is more what native cloud is, because SQS is very well integrated with serverless in AWS, and it's not so integrated with other solutions, like if you have your function somewhere else, function as a service, on another provider.
It allows you to tie in directly to either routing or defining some kind of context, or defining how it's decoded in the case of if you have JSON messages, and maybe there's JSON-based routing from within partially decoding the message, so header-based routing, or most importantly, batching, right? So you might want to give a function, 10 messages, not one, and then solve the hot-cold problem on the function, on the code boots for the serverless functions, or edge functions, which is a more modern approach to it.
It is tempting because
it is helpful. It is helpful. It's just not agnostic.
Exactly. It is not. It's not. Especially if you then follow things like first in, first out strategies in message queuing. It is actually a little bit differently handled in SQS than it is, for example, if you use something like BullMQ.
But that's normal. Like that's
that's normal.
That detail then is basically coming from a point of scale. Where do you partition? Because SQS is still partitioned, but SQS might be partitioned to an availability zone or to an account, right? So you're maybe used to partitioning it to something that you can conceivably attribute to a machine, right? So you say, oh, here's my machine, this is one message queue. I know what this thing partitions, and then everything is replicated behind it, or like a router that might have sticky sessions. You say, okay, so everything is ordered in regards to the load balancer node that I'm on, right? So
Yeah.
it all comes down to this level of detail, and this is more like a vertical sort of DevOps. It's more like the engineers understanding the orchestration of the system, less so about the tool itself not being agnostic or maybe favoring vendor lock-in. Vendor lock-in is good because it might have custom features. You know, a lot of vendors adopted these common services because AWS was one of the first ones to actually take it seriously. And then basically all of the cloud market competed with AWS by being a cheaper AWS. You know, DigitalOcean is notorious for having for basically being AWS but cheaper and leaner for smaller businesses that don't need. I don't even know how many services there are on AWS right now. I think it's over 300 at this point, and I don't even know the names of them anymore.
Yeah, they have very specialized things, like where you build your own YouTube, right? With all the APIs in between that.
Basically.
And you can't do that with DigitalOcean. DigitalOcean is really it's really like a solution for, especially for very small companies up to medium-sized companies who use, let's say, the common standards in which we know of, like having the 3 main databases available plus Redis, having let's say S3 compatible storage, exactly.
Durable technologies, you know, Kafka, Postgres, MySQL.
Kafka is new, right? They provide you managed Kafka right now with a reasonable good price, actually.
Yeah, and I think ClickHouse as well. So that's coming in as one of the most sort of popular alternatives. No, ClickHouse not yet. No, DigitalOcean has ClickHouse, yeah.
But not as a managed service,
but not
as a
managed,
one-click service, right? So it's different. One-click is it's not managed.
Kafka is the latest, I think, on DigitalOcean.
It is. It's
managed services.
Yeah, just as a disclaimer, so we in our company are DigitalOcean business partners, which we often mention DigitalOcean in the way like not many others are doing, because we believe in still they are a very good pick for small to medium-sized businesses. Because they are still agnostic with the stuff they do, which is quite interesting. So they have things like serverless, but I wouldn't recommend to do serverless on DigitalOcean, to be honest.
Daniel Vaughan has a great comment.
Maybe we should go through the comments because they stack up. Yeah.
Daniel said, I would say Google Cloud SQL, PostgreSQL, and Google Cloud Spanner are both cloud-hosted databases. However, Cloud Spanner would say Cloud Native as it is designed ground up to run in the cloud, whereas Cloud SQL isn't. This is really interesting, in particular when it comes to SQL, because we had this, I don't know, how is it called? Like the YouTube influencers like to call this like Neo SQL. So like New Age SQL, essentially, where you're really handling like query orchestration. So I have an SQL query. Which shard should I run it on? Right. So when an SQL database is cloud native, you basically have either a vertical or horizontal problem. You know, either you have Supabase or PlanetScale, right? So which one of the native SQL databases do you want compared to, let's say, Postgres inside RDS? Right, so RDS will always be a fixed size. You can resize it, but it has downtime. So you need to rescale it, scale it up, scale it down. Yeah. Or you might have a shard ready that has replicated data, but is slightly larger, but because it is expensive, you don't primarily run it. And that is not a particularly good strategy for that. But generally, databases have a connection pooling issue. When a connection comes in, I have to open the connection and let it talk to the database to figure out what you're trying to query. But at that point, you're already talking to one or many servers from the connection pool. So I have a routing problem that SQL drivers, so the traditional MariaDB, MySQL, Postgres, etc., never really optimized for, right? So the traditional SQL drivers were never optimized for
Yes.
orchestrating queries, for deciding, for essentially doing Hadoop level or orchestration. It's like, where is the data? Where does the data live upon which you want to run a query? The SQL driver was never really optimized for that problem because it was optimizing that problem for hard drives. It's like, okay, I have an index locally to decide where I should go looking for that data.
Mm-hmm.
And I think Spanner is a very good example of GCP solution to that, and basically the equivalent of Google's internal, what was originally, what did they call it? Their own MySQL, was it Bigtable? I'm not sure. Their own proprietary MySQL implementation before they went to Spanner.
I don't know.
But I don't want to speculate. And what you would now consider Supabase, PlanetScale,
Yes.
and the more modern SQL databases, which are essentially either running on cloud native infrastructure, and then they're basically resizing the databases, or they're shared sharded databases depending on the tier. I think the free tier, which one was it? Supabase, I think, had a free tier problem recently where backups got mixed up and people realized they're on a shared post.
But if we talk about that type, we are already again going into the native cloud area, because if you have solutions which are in a very specific way optimized for scaling.
The quality being auto-scaling. The quality being, I don't have to decide how many write IOPS I want. I don't need to decide what disk space I want my database to be, because that was usually necessary. When you wanted to spin up a database, you needed to decide, okay, what volume do you want to mount? Even in DigitalOcean, you might have to say, okay, what volume
everywhere,
do you want to mount? Everywhere, you have to say, what size volume do you want? If you want something encrypted, is it the entire container encrypted, or is there an encrypted volume? How do you back up these things? How does the database spin up? Does it talk to this one first and then tries to decrypt that, or does it just natively spin up? Can it be hosted on multiple write instances at the same time? Can it be hosted on multiple read instances at the same time? So those were cloud solutions that were not cloud native. There was still some level of sort of machine abstraction leaking through. Of, I know there's a machine, I know there's a hard drive, even if it's a sort of digitalized, abstracted away volume, but you still have to manage partitions. And the cloud native databases don't have this problem where there's a layer of abstraction above it. You don't get past the machine. But it uses cloud native tools to really fix this problem, where one table might not be stored in only one location, but it might be sharded away and optimized for either quick recall or having, DynamoDB is very good at this. If you read the DynamoDB white paper, to basically decide, okay, what are we optimizing for? Like what strategy are we using? Do you want confirmations on at least 2 nodes? Do you want durability? Do you want consistency? Do you want the quickest response, even if it's not consistent? Right. So are you optimizing uptime? Are you optimizing availability? So those, I think, are very good solutions that come with their own challenges. And I think DynamoDB and the more sort of neo SQL setups are, I think, the best example of this. On the storage side, on the caching and message queue side, I think Kafka stands out.
Yeah, but still, to not get the wrong notion, I still consider Postgres as a managed version, the service as a cloud native service, even though that Postgres was never invented to be a cloud native thing. It is a traditional database, like MySQL, Maria, or something like that, which is available in the same idea, or let's say the flavor of how cloud native is actually used. You can't use it in the scale, but if you start to use something in a scale like that anyway, you lose the agnosticism quality anyway. And those things need to be considered. We are still in the context of smaller companies, and smaller companies in most cases don't have that scalability issues. And this is really something when you want to become very large with your data. And again, it is not very realistic to try to brag now with great things and talk about. I don't think we should do that. We should stick with what most of the audience is actually dealing with. And this is so I never met a company on the level of, let's say, 20 to 30 to 40 people who actually had this requirement to really have that scale in mind, because this scale does have other, let's say, problems you will face then, which is to get this all running. Everything behind that need to scale as well like that. It's not like you're having still 5 containers running in a database which is actually made for. No, the entire thing is then growing. Multiple teams, other problems. So let's stay with one context.
Yeah, well, one of the contexts that I think is orthogonal to scale is locality. So you might, especially with digital products or digital e-commerce, where you're selling a partially or fully digital product like courses or videos, or if you're basically allowing worldwide shipping, but you want the front end or some kind of front office to be served with reasonably low latency, you also get this locality issue of, I might want to use a cloud solution to take advantage of the cloud provider has data centers all over the world, and I might want to deploy some part of my application on edge functions or serverless functions, or have certain replicas of the database which are closer to my potential users. And then I basically define where I want that to be. Because usually, European startups and American, San Francisco-based, San Francisco-funded startups, they usually had this problem of, do we put our main database, our main hot database, do we put it in New York, do we put it in San Francisco, or do we put it in London, Amsterdam, Berlin? Right? So where in the world should the hot database be? Because that will impact most of our latency. And of course, I'm sort of biased here, being a Westerner, right? So, but that was primarily the solution that we were always trying to optimize for. And I need an Asia replica that's completely separated to keep latency low in order to avoid the Red Sea cable, the fiber cable, or avoid having to be routed through Indonesia, right? So that's the BGP problems for those of you who are building native cloud solutions before. I used to work in ad tech, so that was generally a hot topic. Packet loss over Los Angeles and down to Indonesia. So generally, you would also want to optimize this idea of my application is per tenant, right? So I need the user's information to be accessible to the user and nobody else. I'll do centralized application asynchronously and only for business intelligence means, which means that wherever the user is from, I want their data to be primarily in that database that is close to them. So that's another aspect. Has nothing to do with scale, has nothing to do with billions upon trillions of queries per second or hour or day. It also has to do about locality, where you spin up a medium instance in Germany, but you don't want somebody in San Francisco to have, I don't know, half a second of latency to spin up, to show the main page. And then you cheat a little bit by caching. And then the moment they take action, you then need to have second, these sort of degrading or either inspirational animations that basically hide the fact that there's something slow going on. Whereas you could just solve it by collocating the database with a replica in another region. So I think that also shouldn't be ignored, because small businesses have that problem, and they are using cloud-based solutions for alleviating at least some part of that latency pressure in e-commerce, especially, or telemetry. When you need low latency input.
Let's go through some others, I would say. We have Daniel said that before. This is quite interesting. So just for terminology, that AWS wanting to own the serverless idea. You hear that quite often. I said that in the beginning as well. Serverless was pretty much even coined by the idea of the function as a service thing, which came out first, and then later it was extended by other services as well. And yes, AWS tried to own it, even though that AWS provides so many certifications and other things in that area, and they really try to own that stuff, which is one of the reasons I somehow very much dislike it. because it doesn't follow a pattern for a good strategy for a business of a, let's say it is serverless isn't really great for large companies because it is no.
I mean, I would challenge you on that notion, right? So
I do it.
there are flagship companies, like Lego is a good example,
Yeah.
that has built their entire e-commerce system from customer facing, front office, their internal logistics, warehousing, and back office analytics on mostly serverless technology, or at least cloud-based technology on top of AWS. Right? So it is.
But this is something different. This is something different. So serverless is serverless, and cloud native is cloud native. Cloud is cloud. Serverless is very specific in this case.
It's unreasonable that serverless solutions aren't using some managed service that you wouldn't consider serverless, like DynamoDB, or like, do you consider DynamoDB to be serverless?
No, I don't know. Serverless is a little bit like serverless is a dangerous thing to talk about and try to define because it isn't defined. The problem is that serverless in a vendor context is defined differently. But if we say, for example, something like, let's say, use the terminology like native cloud. So something where you don't have something anymore which is supposed to run in any form not in the cloud, the native cloud way, which is, for example, a function as a service, because you can't really develop it locally in a way it's meant to be. So it is meant to be developed in the cloud. So it is a little bit like, can you, or I can ask you this, the counter question, like, can you develop DynamoDB locally? Right? Or in a data center. So this is the question you should ask. And I give the question to you, is it possible or not?
I don't think it's practical. I don't think it's, DynamoDB is, the serverless or the cloud.
Then it would be fair to call it serverless.
The federated nature of DynamoDB is part of its architecture. I don't think you can sort of separate it out. You might have a simulation of it to do integration tests, but it's not the real thing, right? So the same way that you might have a MongoDB cluster, an autoscaling cluster, and you might have MongoDB locally, and then you say, well, this is kind of the same thing. It's using the same SDK, it's using the same protocol, but when I'm on production, it's a quite different beast. I can do the same thing with serverless functions. I can spin up the function and run it locally, no problem. But it's not in the environment, right? So it is intentionally boxed, so something comes in and something goes out, and I can spin up the box, but I can't spin up the federated system, because spinning up a simulation of the federated system would be the federated system, unless I have a development sort of staging replica for it, which is just
yeah, but it's not meant to be like that. So it came later in the native area, that in the cloud native area, so no native cloud area and serverless area, that you were able to develop locally. So it was like you had the IDE, and the IDE was directly connected to some form of API, CLI, or something like that, where you hit the button and you saw the execution in the cloud. So this is native cloud. If you force that onto your computer, this is actually a hack. This is not the original idea of native cloud.
Simulation.
Yeah. Exactly. So it's a little bit like, so Daniel is saying serverless, or is asking serverless is fully managed. I wouldn't say so, because because if you take a look,
I would say serverless is when you're no longer thinking about host names or routing. Like from that perspective of, does the user need to be routed somewhere, like somewhere, not to something, right? So in a GraphQL sense, I would say route it to GraphQL, and then GraphQL decides what system to talk to. That would be a routing problem. And if I have a load balancer, for example, and the load balancer says, oh, this user goes to node 7, that would be a locality or load or scale decision. Those are both host aware. Those I wouldn't call serverless.
Exactly. So for example, if you know how many CPUs you run, how large your server actually is, where your server is, how many servers are there, then it's actually not serverless anymore. Serverless is actually a term which is not let's say for the person who operates the service, it is for the person who uses a specific service. In serverless, it should not be called serverless, it should be called service something. So you only use a service which is supposed to be an SQL service, which is supposed to be a function, right? And you just you get promises like how often can you run this function, how much will it cost, which are the limitations in size, for example,
and that's
bandwidth.
the thing that usually, and we have a comment on that as well from Raul. Is it possible that most companies that search for non-cloud native solutions keep the level of vendor lock-in low? What usually comes into mind here is serverless functions often get called function as a service, right? So I don't know why they're not called FAS. Like it is function.
They are called FAS actually.
But I've never seen anybody use FAS as a terminology.
I am using that.
Okay, I'm gonna check your blog post right now.
There is FAS on it, but it's actually function as a service. It's not abbreviated.
No, you didn't mention it.
I used it in other LinkedIn posts. I used actually function as a service back 1 year ago, something like that.
It is useful to say I want my function to be hosted, rather than hosting a container that hosts an application that contains the function, right? So it's not even application orchestration anymore, which is what Heroku is, but actually a level deeper where you basically have a subsystem of the service being OpenFaaS. Is that a thing? It is. Interesting. Serverless functions made simple. Oh, I see. Yeah, there's also the whole OpenTelemetry, the event-based architectures. These are all sort of going into the footsteps of OpenAPI and basically creating specifications for how to define these how to terraform basically these functions, how to define them in a platform agnostic way. Also for structured logging on Elasticsearch and ECS style or structured logging style.
And there we are at the problem. So, it is a little bit tempting to, as a software developer, thinking, oh great, serverless, right? I only need to have my functions. There's a little bit more to it than just a function when you run an application. And you get into, so there are people like, I think it's definitely called Sam, but I don't know the surname. I think Sam Williams on LinkedIn.
Williams, I did a podcast with him.
Yeah, and he's about taking challenges, what you can build with serverless. There is my problem already. Maybe we are not in the age yet, but if I already hear that, hey, we need to take challenges to actually build something, this is an obstacle I don't want to have in my company. I'm really now serious about that. Basically, nearly every company we worked with who used serverless or tried to use serverless failed on some point or the other. So maybe it is because they failed to have the right mindset for this. This is possible. And it is oftentimes a pricing issue. So people ask
higher, but they also want to reduce their cost per traffic or per user. A very good example of this is our AWS Cognito, right? So that is their. So that's not IAM, that's not the internal user management, that's the customer-facing user management. So one that you could actually use as an alternative to Auth0, for example, right? So you spin it up, you have a cloud-native service that manages your users' credentials in a secure way, in a sort of regulated way, and you can have your security level there and your backup level there. So you can have compliance levels there to your discretion, as long as you pay for them. But they do become expensive at scale.
Yeah.
So it's really, if you have a lot of budget, it's really easy to spin up such a system if you have a lot of experience managing such a system, and you can just prototype something very quickly and then throw it away in a month. It's very difficult if you start off like that and thinking it's going to be easy, and then you still use it after 5 years and you never really manage. You optimize your application to use it less. And then you get this problem of, well, it was cheap for 100 users and now we have 500,000. And
this is my problem. You are then locked into something which is not agnostic in any way anymore. Exactly. And even if you use something like OpenFaaS or something, there is so much other stuff, that you always have some form outside of your orchestrator which you need to manage in order to get things done. May it be the load balancing outside, may it be how you handle domains or something like that. But the point is, you need to reduce that to a level where you can move quickly from one cloud to the other. And we are still in the context of small companies. Just to repeat that, because it's an entirely different story when you are a medium-sized plus company and a small company. It is simply like that. You for example, let's take a look at databases.
Yeah.
You only need 2 or 3 types of databases as a small company. You don't even need to think about cloud scaling, native cloud things there. It is simply not necessary, because if you start to do it, as I said beforehand, you need to think of scaling everything else as well on a level you cannot afford. And this is the point. So it does make sense to start with something which always a strategical thing. So never start with something which is cheap in the first year. Start with something which is TOC cheap, or let's say reasonable in the first 5 years. This is your strategy.
And I think that's one of the biggest psychological challenges for CTOs, because I also coach sort of CTOs that end up accidentally stumbling into this area, right? Where they say, I did do the math, I did check the numbers, it did make sense. And then we ended up using it for 3 years, and they changed the pricing strategy. And when
this is a big problem. Yeah,
it stopped making sense. And then it was too expensive to migrate off, because we had a grace period of, well, here's the new pricing strategy. You have 6 months to fuck off, or you pay the new price.
Yeah, but what is
more time, and we needed more time to.
What is if your software architecture and the performance of the functions don't fit together? I saw this. Right. I'm in 2 Slack groups, and inside those Slack groups, there are so many people with they are small companies scaled largely with serverless and running into limits they cannot afford anymore. They spin up like those hot functionalities where they try to avoid getting into some serious deadlock, some let's say choke points with their application. This is they spend so much time and effort into getting things running again, because they can't move away. They cannot move to something different, because they have built their entire setup, every function, every little bit, onto one vendor. And when this vendor isn't good for you anymore, it is basically the end of the technology organization. In the case, you can't move. You need to start a legacy migration in that moment. Good luck, have fun. This is not what you want to do, especially after 2 or 3 years as a small company.
Yeah, the biggest issue is that generally infrastructure concerns are handled either by the CTO or by a specialized SRE or sort of DevOps or platform engineering team. And generally what you'd want in a properly federated sort of microservice environment, if you have that, you would want to have your entire system split up on the verticals of your main business strategy, which is, our business has these 4 products, and these 4 products orchestrate slightly differently. And if we move one of them, we can move one of them independently of the other 3. But in reality, usually all of your products, all of your features will meet somewhere.
Yeah.
And then if one wants to move off, they move off by some part of the base being duplicated and then replicated.
Mm-hmm.
And then you gradually move it over, and then you have double costs in the transition point when you want to adopt cost savings. And that's usually a nail in the coffin for most companies that are trying to adopt that. And then they say, well, we can't afford to go off, so we're just going to stay here and optimize. And that's usually just a downward spiral that they can never really have a good strategy.
You can't. This is the reason why the quality, and again, what is a quality? A quality of agnosticism means that your system in 5 years will be, you are still in between something you have defined, like, for example, a week or a day. I don't care. So you need to define how quickly you want to be able to switch from one vendor to another one. This is a very easy way to explain that to people who are actually in charge and responsible, accountable for the money, right? And you need to explain it that way, how quickly you could change from one vendor to another. Maybe this is not only about money, it is not about scalability. Sometimes it's simply about you have constraints. You are not allowed to work anymore with a specific, because some law changed and you have some new constraints. You need to change. And if you can't do that, good luck. Have fun again.
we-
It is just
yeah.
one of so many reasons to not become vendor locked in.
Yeah,
So many.
We had things like the updates to HIPAA. We had the Russian laws changing before the war, right? Where all data about Russian citizens has to be on Russian soil, so you could no longer use cloud sort of cloud orchestrated user management systems for Russian nationals outside of the nation anymore. So you have to collocate some part of the cloud centers there. I think Nigeria adopted a similar policy to some degree about certain sectors. I think fintech is now coming under this guise of this is becoming commonplace in most fintech or otherwise heavily regulated operations where you can use a cloud vendor, but then the data must not be replicated. EU citizen data must not be replicated outside of the EU, which is very difficult with things like AWS, where you might have. I mean, it is possible with AWS if you set it up correctly, but generally, if you're coming from a US-funded startup and you have, if you're a small to medium business and you're basically having operations in Africa, in Asia, in Latin America, in Europe, and you have systems set up in New York or Florida, and you want to basically de-replicate certain things, it's gonna take a toll on your architecture. You basically have to do a legacy migration before you might even, hit the main cash flow era of your business, of your product offering. So it's very difficult to say, oh, we're gonna do this and hope for the best and it makes sense. We ran the numbers now, it makes sense for the next 10 years. That's a very difficult decision to make because a lot of things might change in 10 years.
You need to stay flexible. So agnosticism is another word for staying flexible. And it is important to have that in mind. So you need to have a vision for the next 5 years, but it is a vision. It is not an exact plan where you walk step by step. You don't know what changes will happen. So I see that with so many companies, they start with AWS in Germany, for example, and they are under European law, under German law, and then they scale, they get new clients, larger clients, and they say, oh, great product, yeah, we want to have it. Okay, where do you host it? In AWS? No. So change it or not client. So you can't scale anymore in Germany. This is one of those problems. It is so complicated because, for example, we had that with one big client and they say AWS is okay as long as you use our account.
Yeah.
And then it becomes very complicated and actually not really doable. And this is something we all need to consider. And it's not enough to just have. It's not enough to just use the derivatives of the US companies in Germany or some. It is not enough. It is simply not enough. Yeah. And this is the same for everything. So, which was one of the reasons I got to CloudFest, where I wanted to talk with other, let's say European-based cloud vendors, just to talk about how they're doing things, how far they are in the game. Yeah, but actually there were not so many there. That's another problem.
But we also have to mention that most, like I think over 80% of sort of Western Europe. I don't know what the situation is in China, but over 80% of funding for startups, for tech companies, for cloud technologies is targeted at the US. Right. So we have to, right. So if we say the baseline is most tech giants are in the US, most tech revenue is in the US, like that's baseline. So we have to admit that, Europe by default only covers 7% of all global revenue in the tech sector. Right. So that skews most numbers if you compare things apples to apples.
Which is one of those problems with all the EU laws, actually. So if you are listening right now and you are in a EU company, you know exactly what I mean. It is a little bit like you are strangely regulated. It is tightly regulated, but you want to have actually the freedom from US companies. And this is because you need that to actually build your company. But those laws are not there to protect companies. They are there to protect citizens. And this is a big big problem actually. Now, not for the citizens, but it is a little bit like it's all about data privacy. It's all about that. It's always coming down to data privacy. In every discussion you have on the floor, it's always about that. It is always about we need to protect our data and the data of our users and stuff like that, because this is a chain. So you have the chain. It is like that, and I don't get away from this point because I'm fighting against that for 50. I'm there for 15 years now, fighting that problem. I'm not actually fighting the problem, but working on the problem. And it's always like that. It is not like your client is just want to have that, because there is this chain. You have the certifications, for example, here in Germany, there's ISO certifications. If you want to have that, you need to prove the entire chain. And everyone in the chain needs to prove so many things. And they are all based on data privacy, actually. And it's all about that. So no leak, no this, no that. And even you can, this is strange. Every incident, everything you don't do in that case, and you found out you have done 1 year without that, you need to report that actually. Otherwise you break law. And this is something which is very awful to do, very awful to scale actually a product, because everything. So I'm not against data privacy, don't get me wrong. It's important to have that. The point is, it is choking. It is a little bit too much in many cases. While you are allowed to use US products, you are not allowed to build the same things. And this is what is so strange about it. You have something like SOC 2, for example, for a very, let's say, very basic thing. Most cloud providers are actually, you can use their services, but companies won't.
Basic. SOC 2 and GDPR are sort of following the same guise of. Yeah, so here you need to have rules, you need to have procedures, you need to have documented access and telemetry about who and when and why and what and how much. And I think those are good measures. I think that's showing a high standard. That's just something we can do. We just say, oh, we're doing it to this standard.
Yeah, of course, but most small companies don't follow it because they can't.
Yes, but this is one of the problems. When the regulators want you to do something you don't do naturally, and it doesn't increase protection, it doesn't actually practically increase protection. I just need to follow it because I need to follow it. All small and medium businesses adopt cloud solutions. When the cloud solution gives you this protection for free, under whatever umbrella term that sort of satisfies regulators. And then you might breach the ceremony around the benefits to either the regulation or the security or the protection by saying, oh, our cloud provider does it, but we internally in the company don't. So I think we're good. And it's just this silly, naive approach to
it is not about doing, it's about certifications. No one cares what you do. Oh, they only care about what certifications have you made and which instances or entities proves that to you. And this is the very expensive and oftentimes impossible part.
And that's my point. Like doing this kind of regulatory protection based on certifications in the EU, I think is silly, because it should be coming from the perspective. We had Brian Finster on a lot of times. It should be coming from the perspective of platform engineering. My CI/CD pipeline should tell me that we are following these practices. Not that there's a human involved and they can look at it and they can say, yes, you're following these practices. If a human can go and look at it, they can tell I'm following these practices. That's already a lower standard, but it is still the highest standard if you're following normal business, sort of enterprise level, especially in fintech and other highly regulated industries. If you're following normal sound practices where a human regulator comes to audit or to give you a certification, and you might have to do an exam, or the entire I don't know, senior management has to do an exam, and the company has to be audited by a third-party independent auditor, right? So I think as long as these things are not automated, and especially in Germany, they are not. Like, you guys run a lot of bureaucracy on paper still, which baffles me. You're a nation that doesn't use credit cards, and you're a nation that just refuses to do e-government for some reason. There's a lot of printed and faxed things still going on. And I heard even
we have in every system we manage for German clients, we need to still provide fax numbers.
Yes,
That's
that's
awful.
and that's what I mean. And that's what I mean. Like that's like if I'm drawing this like huge line about we're so strict that we're much more strict than the Americans, and then we're faxing things over in plain text. Like, guys, come on. Like this
No
is
one is
not,
faxing actually, but everyone is saying, "Oh, maybe
know,
we need
no.
that." There is some fax in a German company still, but let's get back to actually so let's get back to some comments, right? Jeff asked, or is it a question? No, it's not a question. You can get other people to install hardware you own into racks that are run and managed by others, so you can own the machines and never actually touch them. I would not call this cloud native. No, this is not cloud native. This is
Hetzner was notorious, and this is basically a VPC. You are renting a virtual. I'm hesitant to call it box, but you are essentially you are renting a port on somebody's router that is connected to some virtualized operating system.
but if you buy it as I think the emphasis is on the people who manage this, and for me this is just a standard traditional infrastructure as service approach.
Yeah, no, I mean I wouldn't even call it infrastructure as service. I would call that a traditional data center business model. Like that's
Yeah,
how
we called that 10 years ago already infrastructure as service. So we paid someone to actually make, even though we own that environment, we don't manage it. It's not for rent. It is just a service. You pay someone to do the service for you.
Fair.
It is not basically SaaS in that case.
Yeah, I'm trying to poke holes into it from considering, do they have access? Do they have port access to it, or do they just install components?
No, you just have one person or a company who manages yours, basically the stuff you own.
Your rack.
This is just exactly. This is how we did that. Or actually, we still have a data center running where it's done like that.
But generally, in data centers that I remember, it was usually our people managing the rack with help of somebody else, with help of somebody from the infrastructure as. This
is so many this is basically defined by contract. You can do that individually. So this is the old world. This is before cloud native.
But then again, once we started renting servers in Africa, we basically said we know how it's set up here, and we want the equivalent there, and we don't want to fly somebody else. So you guys do it, right? So yeah, you're right. This is
one of those reasons why cloud native was invented, because no one wants to do that.
Nobody wants to do that on a weekend at 3 a.m.
Especially not in downtime or not in outages. So Daniel then said, cloud native for me is about an architecture style that makes the most cloud strength, and mitigates its weaknesses.
What are the weaknesses of the cloud? Like, other than cost?
The weaknesses of the cloud, and the cloud is such a high level terminology that is a little bit hard to answer that question.
If I do a fully federated terraformed Kubernetes cluster with 200 microservices and a bunch of managed services on AWS, what are the weaknesses of that approach?
This is not if you have Terraform is not dedicated to cloud, and Kubernetes isn't either. So those both technologies were not invented for cloud or cloud native. They are used there, of course, as a standard, same as Postgres and the other things. So the weakness of cloud. So what could be the weakness of cloud? It's a little bit like the fears. So I last year had my keynote on the CloudFest regarding how to become cloud native or cloud native culture, and most people still have the problems with. What is with my data? Where is my data? Who owns the data? All those things. This is still a big thing going on, right? And the other part is that you don't really own those things there. The part with the agnosticism, and stuff like that. So what happens if something goes wrong? And this is in the beginning of let's say the first cloud providers who offered you some services. It was often like when there's something broken, you needed to call the hotline and you hope that someone could help you. And it was a little bit like it wasn't really self-service, and cloud native is more about self-service, so you can manage the entire thing. But I don't know if cloud native really mitigates those problems, because they're actually on the same basis than cloud. So it is cloud, right? So still you need to rely on that companies or providers, cloud native cloud providers, provide you something which is actually running. And because sometimes it's still there that those things break. So they offer you, for example, something, or let's get back to managed services, right? You get a Postgres, but they offer you a failover. So why do they offer you a failover? It's not because you break an instance, it's because they don't manage to keep it up. So this is the point. And this is actually, again, the same problem like you would have if you manage it yourself on your own hardware, because you need to take care of that yourself. So I think the weaknesses of the cloud itself are the very same weaknesses as we had for ourselves. But the big point is that actually professionals who are doing nothing else than this are actually doing that for you, and they, with a high chance, are better in that than you are as a company. You are actually creating software and value and features for clients, which is one of the reasons why cloud native is developer driven and not operations driven, which means that many of the cloud native services are boiled down to a simplicity that developers can use it. And this is, I think, the key fact and the topic of the title of this session, why cloud native is actually a game changer. It is a little bit like cloud was already there. So we had a discussion on CloudFest with a company I don't want to mention right now, and it was about managed Kubernetes versus manage it yourself. And they always said, hey, yeah, it is cheap. You can use it. It's cheap. It is just some bucks here. You can all do it yourself, right?
Just for context, what does managed Kubernetes mean? Which part of it is managed? The repository side, the orchestration side?
Yeah, actually, so for me, as to explain it now for non-professionals, I would say you click on a button and an entire cluster is provided, is provisioned for you in the next minutes. So this is what manage is for you. They manage the update cycles. They manage which cluster needs to be basically
the update cycle
updated exactly on those kind of things.
Yeah.
So this is what managed in these terms means for me. So it is managed in that way that I can just consume it and not being, let's say, I don't have influence on the actual maintenance of that kind of thing. They can offer, yeah.
Daniel did have a comment on this, right? Daniel said for serverless, you need to be able to drop down an abstraction when you reach limits. For example, in GCP, you can start with cloud functions, drop the cloud run. When you reach a limitation, then drop the GKE autopilot, then to GKE, then to containers on VMs, right? So this idea of my whole Kubernetes cluster is self-managed. I can easily envision a cloud run equivalent of that, where I say, I have an image here, I don't want to manage it, I will give you access to my repository, and as long as I tag it correctly, it will appear in the cloud, which is the whole idea behind Docker Swarm. Docker Swarm was set up in such a way that you can create a Swarm configuration, and you can give it to us, and we will manage it for you. But there is still an aspect of the management that has to be managed, which is how does it update? What the fuck happens when you change the config? Does it die? Does it have to create some kind of quorum about which ones? Do we kill everything? Does some services go away? Do some services restart? What happens if you rename something? Does the old name stay? What does the transition look like? That still has to be managed. That's still a complex operational procedure. Right? Exactly. So it is very difficult to draw boundaries on where does management stop and where does management start. When we're talking about something so infrastructure.
There is no definition. So, for example, if you go to databases, there are providers who offer you for example, Postgres again, offer you a managed version without backups. Some offer you with backups. Some offer you with some additional things like offer you the connection pooling, and some you need to do it yourself. And it is a bit like that. The key aspect is that you don't, in a professional sense, it means that you actually don't take care of the actual maintainability of the service itself. You use the service. It is provided to you on a level that you actually can consume the actual idea and service of that. But you don't need to make sure that it's actually running. So, for example, Kafka as a service, we talked about that. You mean you can use Kafka, you can configure Kafka, but you don't need to update it. You don't need to take care how to actually scale it. So you want to scale it, you press a button and it scales. Or you have an auto scale or something like that. So this is what's so there's an abstraction behind that which covers that for you. There are people behind that who are doing that for you.
But the auto scaling part of it, I think that is fascinating. And Daniel, great comment, by the way. You've been killing it with the comments today. Thank you. I think the biggest piece of the sort of game changer aspect of cloud is that even when it is auto scaling, the cloud-based solutions generally, especially databases and message queues, they remain operational while scaling. I think that's generally the most desired quality that we want in a cloud-based solution. That even when I say I need to scale it up, even if the decision to scale was manual, the system remains operational as it is scaling up. Now, that might have some consequences. If you're scaling up RDS, and if you're sharding RDS, that will have consequences on what exactly happens. If you're scaling up MySQL and you have write-ahead logs, no problem, because you can replicate those. Postgres doesn't give you that luxury unless you're using extensions, but AWS didn't support that until recently for Postgres because it wasn't part of the spec that what Postgres supported. Because generally what we forget is that most of these managed databases, they run a slightly modified firmware of the open source technology that you're using. So AWS runs a very specific subset of Postgres, not what you would call open source Postgres, even though it is open source Postgres compatible. Same thing with the Azure cloud. Same thing with the Google Cloud is still a mystery to me about how it's named and what everything means. I had to Google a few things about Daniel's comment because the Google Cloud
it is oftentimes the problem that this is actually the big AWS idea, right? That we don't talk about general terminology, we talk about their specific terminology because this is like a marketing thing, and we shouldn't. So it is not, let's say, if you don't know exactly what a specific service does, it doesn't mean that you don't know about cloud native, cloud or in general or something like that. You can't and you shouldn't, because it is something different if you are a specific person who is only helping getting companies to get things done in cloud native way or make a transition to cloud native. This is a little bit different. But if you are, let's say, which most people actually are, if you are a company or part of a company, then you need to know about your context, what you actually need, and what are the specifics of the cloud vendor you have decided for. Because what you don't do is you don't question your own decisions every some month. So for example, if you have decided for a vendor, and this most people do that, you do that at least for a year, 2 or 3, right? Before you start to change, because the costs are way too high to actually do that. Gnosticism is great, but it's still a cost factor to actually do that.
And not just the monetary cost, but the cost, the cognitive cost, attention, planning. Keeping the lights on or maintenance activities rather than following your product engineering goals or your product engineering roadmap. Daniel also mentions, the vulnerability weaknesses might be security, reliability compared to data center with a specialist hardware and a physical moat around it. The weakness is due to being built on commodity software. I think the game changer benefit of cloud technologies especially, is that it is being operated by a team that has triple shift duty and 24/7 surveillance. And you generally, as a small to medium business, can't afford that, and nobody wants to work for you to do that job, right? So when we were managing our database clusters ourselves, the worst, all of our sysadmins had pagers, and that sucked. It sucked to carry a pager all the time because you might have an outage at 3 a.m. on Saturday morning, and you gotta fix it. And with the cloud-based, the managed services at least, you get some guarantees there because they might be able to. They might not have 3 shifts covering the cloud infrastructure, but they might.
But they actually
operate-
have. They actually.
Oh no, but I mean they don't have 3 shifts locally. They might in the U.S. But the point is that by virtue of scale, all they need to do is just span 2 or 3 time zones, and then they can constantly have at least somebody who can cover for the adjacent regions to be able to at least remotely digitally fix a problem, and then basically have everybody on shift locally with a second shift rather than having 3 or 4. Right. So if you want 24-hour coverage, you need 4 shifts. And that's tough. And that's a lot of manpower to cover that many data.
But this is the reason why you have oftentimes in data centers, let's say the data center personnel, and then you have actually the owner of the racks, which are different companies. But the data center owners, they have some form of basic SLA, some kind of first level support, and they can already mitigate several problems
They
like
have
restarting
first
things.
responders. That
Exactly, and this mitigates already, and this is actually part of some certifications. So this is one of the reasons why you shouldn't run, let's say, service in your office building as a small to medium-sized company anymore. In some
I see that so often.
build
bro.
racks, you shouldn't do that.
I have seen people build, office spaces which are in Europe. I don't know. Is anybody of an audience here from the Americas? But in Europe,
Americana, any money.
In Europe, generally, most downtown capital city zoning is mixed zoning. So it's generally a mix of business and residential, unless you're in a skyscraper. And even some skyscrapers have residential areas. And I see a lot of offices which are built in mixed residential places where the zoning is meant to be mixed. And you basically need industrial flooring for a server rack because it's very heavy. And I see a lot of people just installing server racks and then upgrading it and upgrading it and upgrading it on residential flooring in an office building. And then when it comes to converting it into a server room because it needs to be locked and
there are so many more regulations to that, like airflow and fire suppression and blah blah blah.
And sucking the oxygen out and the safety protocols around that. And there are, if you're building a server room from scratch, please don't. Just
if you have a NAS, that's okay. If you have something where a pizza box is fitting in, you shouldn't do that yourself.
But don't let your NAS plus some kind of like local storage become your server room that you want to scale. It is not feasible to scale. And I see this all the time, especially small, medium businesses that have made a name about servicing, and I don't know, on the Balkans is super, super popular, servicing local government or local telcos or servicing local bank adjacent services. Things like authentication services or having an software as a service being provided to a bank by giving them, every 2 years a new facelift to their boring traditional mobile app. And they end up building these like weird data center structures, and they end up building this ridiculous fake server setup systems because they say, oh, we're in a regulated system, we can't be on the cloud. And they end up building something completely nonsense because they don't want to use the bank's private native cloud, whatever it is, because part of it runs on COBOL or Fortran. And it's just such a level of stubbornness in Europe that I think at least the Americans have a huge advantage on that.
Let's quickly go through the comments and then to the actual topic of the stream.
Rant over.
Because we still stuck with try to explain what cloud native is, but not why it's a game changer. So we have here something. Thomas, are the costs of company transparent and can be planned? I find vendors' pricing presentations very strange. Well, I think AWS is famous for that, to be very intransparent, and it still
It's
is.
obfuscated.
And,
right?
and other companies take advantage of this and say you have some form of fixed pricing. It is still like a pricing per unit or something like that, but you see the maximum prices. And there, for example, I remember ECS from so Elastic Container Service from AWS, and we had spin up a test instance with a freelancer back then when we forgot to take it down, and there was an update in the in the VCS and GitHub, which was actually broken, and it was basically rerunning the deployment process all the time, and every time it basically runs the deployment process, it pulls the image again, and this transition or this transfer from the image to the ECS instance was actually built. And the problem was we found that out, I think 1.5 months later. So no one cared about this instance.
Yeah.
And then suddenly we got these invoices for that kind of stuff, and it was quite expensive. So I think it was something like 700 euros or something like that you need to pay.
I mean, the biggest unexpected bill that I got in my in like a company that I worked for was 30,000 euros in 2007, I think.
Mm-hmm.
It was quite a hefty bill.
I left that instance on, right? Poverty reasons.
And that was on Adobe Cloud. That was on like the old sort of Flash media servers and video streaming and video editing. Just because same thing, egress costs, right? We thought that internal transfers between our two VPCs that are co-located inside the same private network would be, we own A and we own B. We copy it from A to B. Why would I pay for that?
I think now as this again,
but that was
as
an
a small
assumption. But that was an assumption because I read the documentation and they said, yeah, you pay this much IOPS, and if you download it outside of the data center.
But this is the point what Thomas just asked, because he said in quotes strange.
Yeah,
quotes,
it's not clear exactly what the boundary
is. It's not
like,
clear.
What is an IOPS? Yeah, what triggers 1 unit of IOPS?
And not clear is a business strategy, but not for you, but it's for the vendor, right? So you need to use it, you get a lot of credits, and then you are bound to that vendor. And suddenly you run into these problems where you already see when your credits running out that you say that you think, oh, that will be expensive.
I think that's naive. And I think that's naive. I think most people who are on AWS don't even have credit alerts set up, so they don't even know when they run out. Like that's the point of certifications. Like it is obtuse to some degree, and they want you to just go and do a fucking certification so that you learn all of the nitty-gritty details about what you have to actually manage to self-manage it, so that you don't end up having these issues. But then you end up basically double paying. Like somebody will have to redo a certification every year. And if that employee isn't if you don't have a culture of keeping employees for 7, for 10, for 15 years, then you basically have to hire somebody who already has done that certification where another company has paid for it. Otherwise, you end up constantly having this problem of, I need to certify at least 30% of my developers to be able to, and it's just this constant annoyance of.
Okay, I think so. Yes, there are providers who provide you a very good overview of what you actually can expect, and others don't. So take a look for the providers and take a look of actually your company size, because the larger you get, the more complicated it will become to actually predict that. So it is a little bit more like oftentimes larger companies don't predict that upfront. They just take a look in a retrospective, because it's not so. It is more like an optimization process for them. So if it costs something per month, it is like that. But they try to optimize it. The smaller you are, the harder it hits your budget. And this is what you need to consider as well, which in my opinion, and I have that oftentimes with BWG, which is so some kind of info statistics company, and we talk about that quite often. Yeah. No, it's not in Germany; it's a US company. It is. It is. Greg is the CEO, and we often have that in those phone calls with a lot of other CTOs and people like that. That we basically talk about how you do that for small to medium-sized companies, because when you do small to medium-sized companies, we often, or basically every time, come to the conclusion that AWS is not for you. The point is that many startups are caught by AWS with, let's say, credits like really like 20 to 50K credits for a company which doesn't have a product yet.
But that's generally from seed funding. That's coming from things like Y Combinator and similar venture capital funds, where they have a very generous and usually bloated valuation, and then they unlock 10, 15, maybe a third of the funds of the financing immediately upon successful seeding. And they go slightly beyond that limit by giving them credits, because then they can do that tax-free, or so they can basically write that off as tax-optimized spending. And then they basically think that, oh, for the first year, our cloud expenses are free, so nobody ends up thinking about it, which is a good thing if you do it short-term, which is extremely toxic if you end up getting used to that kind of thinking. And you basically put everything, I can spin up, I can hire somebody and create a server for it, or I can just use some of our credits. And if you then end up hiring nobody and your founding engineer / CTO ends up doing all the work, it's possible that you don't have a viable strategy or even a business model that would support that by the time your credits run out. And if you didn't prove product market fit and didn't grow to the degree that you need to, you might not actually have the cash flow or the second seed funding to actually continue existing. And then you end up having to weird.
This is the reason why I often recommend another strategy, which is to stay agnostic and then basically start with a cloud vendor which fits your current requirements and qualities, and then you have the ability to change later without a big problem. And this is actually a good strategy to do. And always be aware and understand what's going on. So if you have the feeling that you don't understand your pricing model, then you probably have other problems. And this is what you should take into consideration as well. So you need to have a clear understanding of what you're actually built and pay. So there's nothing in between that. You need to understand that. But yes, let's go to the next one then.
Yeah, we hear a few more from Daniel and Kalayan, and the rules one I think we already to some degree addressed.
Yeah.
Let's
go through them.
Yeah, to really optimize location and service, you may have to build it yourself. Some companies with extreme requirements still do this. Yes, but again, you might build it yourself by renting, a managed rack, or basically have infrastructure as a service, and then you have a team that works as infrastructure as code, and then the code goes into the managed. And I think that this also aligns with Daniel's comment about managed Kubernetes is you only deal with the worker nodes, for example, right? So you might do this, right? So you might rent a managed Kubernetes cluster here and in the US and in Africa and somewhere in Asia. And then you basically deploy your you deploy your cluster configuration with some maybe some specializations, but depending on the region, about having to spawn something here and not spawn there. And then you basically go off with that. But when locality becomes a problem, it's really difficult to manage hardware in a city, a region where you don't have a physical location. That's the main issue. That's the main issue. And especially I remember in Ljubljana, we're fortunate, right? So Ljubljana is on the main north-south fiber optic channel that goes through Europe. So in Ljubljana, it's really easy to have low latency fiber data centers. If you're 400 kilometers to the east, it's not so trivial anymore, right? So it's really hard to get the same level of quality to the internet in Budapest as it is in Ljubljana, just because we end up, geographically, we just closer to the fiber. So if you want to host everything in Budapest or Bratislava, for example, I mean, Bratislava is a bad example because of Vienna, but let's say which one isn't on the main backbone? Warsaw, I think, isn't on the. I mean, Krakow wasn't on the main backbone for a very long time until it became had this sort of.
Warsaw was nearly always was.
Yeah, Warsaw was, but Krakow notoriously, until it started booming digitally in the sort of early 2000s, you didn't have primary optics cable. If you're playing multiplayer games or hosting video streaming from Krakow, you had a lot higher latency just to London or just to the Netherlands.
It was really, if you were from that region, if you then wanted to have local, co-located, or at least in your city that you can physically visit and sort of maybe inspect, it's very difficult to maintain a certain latency, right? So that's why cloud, that's the big game changer, I think, for cloud, is that you could keep the servers where the cables are and not have to open an office there and not have to have people on call and go on a flight and go to Hamburg and go to inspect the server and then fly back in the evening and then.
This is actually, let's say, this is a game changer on the very low infrastructure level. Let's say this is a big, and it is a big thing. So we always had the luxury to live close to Frankfurt, which is one of the main backbones in Europe. And so we never had a big problem. So most data centers in Germany are in Frankfurt. So it was always good to have it there. But I know it already here. Well, now I'm living not in Frankfurt anymore, and this is already becoming here a problem to actually having good internet connection somehow.
Yeah.
I don't know. It is a little bit like that. But let us go quickly through it because we are really running out of time today.
Yeah, I'm doing it as well. So Carlo mentioned lots of back data centers in Ljubljana as well. Yeah, there are. Just because I think this is called Styx. Is it Styx? 6. I don't know. I forget the acronym. Fiber optics. Fiber complex. I think it's called Styx. I don't know. I will have to check it some other time. But basically, there are a lot of fiber cables around Europe that are managed as a priority isolated service for banks, for security, for NATO, for air traffic control, and then there's the consumer grade, and then there's B2B, and then there's the consumer grade sort of traffic. But that's basically the leftovers. So in Ljubljana, we're fortunate we have very good internet. In Europe, in general, just because of this infrastructure, our internet is much better than in the US. And we just basically Europe is now starting initiatives where they want to get fiber to every farm, to every rural landscape across the EU. And these initiatives are very successful because the digitalization of the entire countryside is a huge, huge boost to people getting onto the internet, learning something new, or being able to connect with the world in a better way, and then basically end up moving to a city or the capital at some point because they just connect or digitalize themselves to that degree.
Yeah, this is we see, but this is let's don't drift too much into that direction. So because then I start with Starlink and satellite connections.
I mean, you do own Starlink, right? So
yeah.
You do have a Starlink antenna, right?
Yeah, it's actually doing quite well. So it's I have some screenshots here, but I do this maybe in another session someday.
Okay.
Why Starlink is actually good for some digital nomad person, which I am not, but it would be if I'm doing that. So we have some more comments. Do we have? We have.
Yeah, Colin said Rails had a tremendous impact and influence first on VPS and then on cloud. Back in the time, it wasn't that easy and friendly to host. Yeah, I remember those days. I'm not very versed in Ruby on Rails and the Ruby ecosystem in general, but I do recall they had a very positive influence on Heroku, I believe, right? Like they sort of propelled the primary cash flow for Heroku. Heroku was primarily a Rails managed. Do we call that cloud, or was it more VPS? So yeah,
it started with VPS, but it was already back then called cloud. And later they defined that cloud needs to be self-managed and on demand.
Yeah.
And this comes later, but it is a little bit cloud native is a very old terminology, for example, by itself. So it's 2010 or something like that. And it changed quite often when the Cloud Native Foundation then coined it. It wasn't a very original meaning so I had so many discussions on CloudFest last year about that with other people from the time.
And it also depends who you talk to, right? So if you talk to people who are in fintech or banking, they always think about this. Oh, we have a private cloud, or they have a private internet and they call it a cloud because there's so much infrastructure with it, and it's basically a lot of network topology going on, and they call that a cloud, but it doesn't really allow you to host managed services.
Cloud is not a synonym for service, right?
Yeah.
It is own cloud and next cloud are no clouds, and it is a little bit like it is a little bit like
Own cloud is not a cloud, yeah.
it's not just because
It's just a
people don't
VPN
understand
on
what
the-
service are, right?
Yeah, just VPN on the internet, yeah. But it doesn't
But
actually.
I would even say what I see today on Cloudflare still is so many hosters for WordPress. So many hosters for WordPress.
Yeah, I think the PHP world, but that's interesting because
Yeah.
the PHP world was dominated by this shared hosting vision of, like we can PHP is so cheap that we can host it on anything. So as long as you have a secure database, you can just do shared hosting, and then you have the file system issues and the user issues and the security issues of people being able to hack into your folder, user account, server shard, whatever it is. And I don't know why it got so popular. I think it's just the advent of the internet and a little bit of legacy, a little bit of nostalgia. But I really don't see why PHP is still the only runtime that doesn't have its own either. I mean, it does now, but it's written in Go, some kind of event loop orchestrator or request manager. Ruby on Rails has it, Python has it, Go has it, C# has it.
So let's. I see so many people from PHP migrating to other languages right now. Some in Symfony, Laravel may stay, right?
You have Franken PHP, you have Swool, you have like the event loop orchestrators, which are written in another.
I heard of them the first time right now, so it is a little bit like I don't know them, and they are not commonly used. And I think the PHP stuff is some strange in between two worlds thing, a little bit like. No, not even like jQuery. It is a little different. So the WordPress thing is still booming, and no one in LinkedIn is talking about that. So it's a little bit like it is some kind of world stuck in the past, but still present and bigger than everything else, right?
I would wager that even the biggest, Salesforce level enterprise still has at least 10 WordPress instances somewhere because somebody in marketing said, "Oh, let's just spin up a WordPress instance."
Yeah, I thought to myself, there's a hackathon in front of CloudFest, and I said, "Yeah, create a hackathon. Let's go there. What is it? WordPress."
WordPress, yeah.
No.
So there is.
No.
So
I come second day.
WordPress, I think, has a genius business model about being a managed service first that is running on open source technology, but it translated terribly into the cloud ecosystem.
The point is, I was on a presentation of the CTO of WebPros, which is actually a WordPress hoster, as far as I understood. It's one of the big sponsors there. And he was basically talking about how his grandfather was doing a winery business, and he sold those stuff locally, and later they built something around WordPress.
Typical European startup stories.
This is one of those reasons why WordPress becomes successful. We had things like Elementor, which made those were the pre-things like we know from Wix or from Webflow today. We had that with Elementor back then. Quite expensive software, but it was possible to build a very good website, CMS-based website, by yourself in some form of cloud back then. And this was actually the pattern for Webflow. What they actually need was there already. And I think this is what made WordPress so successful, is that there was nothing else. There was Joomla, something like that, but WordPress won, right? And there was this blog boom, so WordPress started as blog. Later on, it became a shop with WooCommerce and stuff like that. And so it is not fair. It is not fair to blame WordPress for anything. It is actually a solid software for specific purposes. The problem what I had is that WordPress was misused on some point for everything else. So for real application management. So I saw then entire businesses, 200-300 people, used WordPress as a back-end solution for their company. And this is not what it's made for. It is not able to scale in that way. It is not able to fulfill all the principles we're talking about. It is hard to work in that. It is a plug-in based environment. This is very old school. That is okay for a blog purpose, but it's not okay for a real application. And
20 years almost to basically for Shopify to come along and to take away some part of that market, right? Because I think Shopify was the only other competitor that reached
To WooCommerce back then, yeah.
Yeah.
And WooCommerce is still a thing. So you can go to internet, take a look for your shop software. You will find WooCommerce, and there's a chance as a non-techie that you pick still WordPress site, which is the reason why WordPress is so common. It is easy and cheap to manage, right? It is it is reliable, it's working, and there are 1 million plugins there, and there are 1 million developers there, which you can get for quite cheap money. And this is one of those aspects why this is still a good small to medium-sized business solution, but it's still strange to me. I don't know. Let's go to next topic. Yeah.
Carlo and Daniel had a good comment. Carlo said it used to be cloud equals not on my machine. And Daniel mentions, I would argue on-prem Cloud Foundry would have been a cloud-native platform because of the abstraction, right? So
I would argue on.
So you would host your own rack, and you would basically put Cloud Foundry on it. And I think Oracle had an equivalent. Oracle Cloud was, and the old Nokia servers, but I think for back in the telecoms, late 90s, early 2000s, Nokia was still a very large sort of private cloud, native cloud, or sort of private internet vendor where they could basically send you a server and then you could host a giant network on your local infrastructure that you could then put on the internet or not. Like you could then decide whether if it's an internet or if it's a cloud, and you could run services on it. That's the point.
So cloud native does have nothing to do with public or not public. So I don't believe in that. So I would agree to what Daniel just said, because I see that there are people like Gridscale, there are people like, especially those private clouds, and they are private clouds, right? And you can do cloud native in private clouds. And private clouds are often using Cloud Foundry. They're often using similar things to actually run, or even Terraform, right? To run those things. You can, even if there is a platform team, right, who is managing like something entirely different, like Docker Swarm clusters for you, and you just consume that.
But it's also historical, right? Because Cloud Foundry, if I remember correctly, that's the whole. How did it go? VMware, and then VMware Sphere, I think it was called, or Nexus, and then you'd basically go from kernel virtualization to container virtualization. You're basically you've bought hardware, but it's not being utilized all the time.
Yeah.
So you split up the hardware into containers, and you buy an enterprise grade VMware license to manage that, and then you self-manage it. And then to some degree, you then connect that up with other servers on the network, and then to some degree, you then connect it up with other hardware machines over the internet, but might be through a private optics fiber cable, and then that you then end up calling a cloud at that level of abstraction, and basically the whole VMware.
But he's mentioning especially cloud native now, and I would say that cloud native is the aspect to build something on some kind of service layer. So it's not like you prepare the hardware for that, which means that as soon as the teams who are working on the software should not work on the hardware. So, which means that if you have in one company, like a platform engineering team, this is what I meant, is using cloud. Even if you use CloudForge, for example, they would provide you something which you then consume, and you build it in the cloud native way, and then it's okay, because it's about the cloud native way, which is an easy form to. So you build it to be supposed to run in the cloud. Right? Yeah. And if the cloud is locally, if the cloud is on private, if the cloud is somewhere, so even if you would build something for some kind of large intranet which would have a cloud, it's okay as well. It's pretty strange because cloud, right, is somewhere else. But it is still, let's say.
I mean, cloud was meant to be nowhere. Like that was the core idea behind cloud, that it's nowhere, that it is the abstraction above the locality, right? So that it is primarily that's what the internet was supposed to be originally. That it is nowhere.
But exactly. But cloud native is not cloud. So cloud native is the idea to build something for something in a specific way.
Daniel mentioned it as well. He said cloud hosted is the where, and cloud native is the
exactly. So it is the cloud native way. This is what we often hear. It is how you build your application, right? And this is, for me, again, then, what is the difference between native cloud, which is only built, it is built inside the cloud already, which is the next step, the next evolutionary step of
You're
cloud
building
native.
an application that has a interface layer embedded within itself that separates it from the cloud vendor, basically.
Which one? No.
The native cloud.
The native cloud is best described as serverless. Actually, this is the easiest way to describe it.
I hate that oversimplification.
But the point is that you actually imagine in a very simple way that you actually you build something inside the cloud for the cloud. Cloud native is not necessarily like that, which is oftentimes called that. Serverless is a subset of cloud native, but cloud native is not a subset of native cloud or serverless. You can't only turn it in one way, because cloud native was there for 15 years now or more, 2010. But it is like in cloud native is a little bit more open in its definition, while native cloud is very close, tightly, even vendor specific. And this is the big difference. But there's Thomas is there.
Thomas there.
Thomas 1.
The other Thomas, yeah.
No, this is not the other Thomas. This is the first Thomas. Thomas 1. That's a different. We need to be. Yeah.
WordPress is very good for the start. So WordPress is amazing. I used to manage it in every part. It is easy in every part. Also in the business and open source. And if you're good in the system, not good in the, or not, you can start with everything what is needed for a standard business. Yeah, I agree. With that.
Especially
if you're a PHP developer. Yeah.
PHP developers are used to work like. Let's not be mean, but it is. For PHP developers, it's great. For everyone else, it isn't.
Yeah. Okay. If you're a PHP developer, it's like a pig in shit. But if you're a cow and you like grass and
WordPress is like for PHP developers. Someone understood me.
Yes. Yes.
Yeah.
I have a PHP background, so I get it.
I'm a development punk. I
was a PHP developer that loved to work in PHP frameworks, but I hated working in WordPress. Like WordPress for me was just cancer.
I loved Zen Framework too somehow. That was my favorite framework back then. Mm-hmm. Okay, I was looking for a Java backend and continuous cloud solution. Good is Heroku and push to Heroku and DigitalOcean. Who's actually saying that?
I think that's also Thomas. One of the Thomases.
Okay. So Heroku and DigitalOcean are oftentimes compared, and there's for good reason, because even though the DigitalOcean does utilize Heroku software, and for the app platform, for example, the only really good solution I'm willing to use in the SMB area. So I don't like very much Vercel. So this is a very specific to me. This doesn't mean that it's bad, but it is some strange form of Jamstack serverless thing. I don't like that. And what
so it's also very expensive. It is you're still exposed.
It's very vendor locked in, and I don't like that. So magic functions and stuff like this. This is not what I as a CTO consider as a solid foundation. It is good for Jamstacks. It's good for very small companies doing one specific thing and want to scale that. That's okay, Jamstacks, but not real applications. And so don't forgive me if you consider, but Jamstacks are small, very agile things, not meant to scale up on a level where you have a real backend. And DigitalOcean, just to say that again, so I need to disclaim a little bit that I am a DigitalOcean business partner. But I decided, we were clients ourselves, so we are still our clients with the app platform. And there is a specific, very well-designed aspects around cloud native for small companies, not for large companies. Because for large companies, I wouldn't even consider DigitalOcean app platform as a real cloud native solution anymore. This is in the various context specific. And the reason for that is that you actually have one platform where you can build the application in a cloud native way, and you don't have an hassle at all. So it is basically your interface is a YAML file, pretty similar to a Docker Compose file.
It doesn't make sense to orchestrate with, let's say, if you have 50 teams that manage 100 applications.
That's totally not the thing you should use.
Yeah, permission management gets really difficult. It gets really difficult to sort of create boundaries between the teams. Yeah. So it's not, and for that you use AWS.
Exactly.
That then becomes enterprise grade, and you need, at the very least, some level of bureaucracy above your cloud.
Governance.
Still,
Yeah.
some governance above your cloud that still allows you to use the same credit card, the same, let's say, custom contract if you have one with the cloud vendor, because you might have a discount or per seat credit or something, without actually.
But in that
exposing
scales, you don't have a
all
credit
the-
card anymore. There are options in larger scales that you
You'd be
don't have.
surprised. You'd be surprised how many outages happen because somebody's CFO had.
This is the reason why very large projects don't use credit cards anymore. They do that directly. This is another talk. Yeah, okay.
But you need a custom contract for that, so that happens at extreme large scale, but not. Okay, anyway.
There are the.
Daniel mentions CloudFront Haiku from Onsi Joe. Here is my source code. Run it on the cloud for me. I do not care how. That's nice. So I think that would be basically the equivalent of Heroku. He mentioned Heroku, self-hosted Heroku, right? So I have either a function or a service, and I want to define. Please use this stack.
Yeah.
Because it's written in Python, it's written in PHP, it's written in X, and run it. I don't want to define the Linux system that has to run it, which is the main Docker problem with people who go from hosted services to Docker, is that they have to manage some part of the metal about what is running on, is this Debian, is this Ubuntu, what version of it, what are the packages, what are the plugins. A lot of developers that I see hate that aspect of going into containerization, and then it's not fully managed, and they have to sort of do that sort of diligence of keeping their own custom images up to date. They don't know which one is the main streamline, most popular, fashionable PHP image to use right now, or which one's the primary PM2 Node.js image to use right now. And serverless sort of abstracts that away and says, look, I have Node.js version this and that, and please run it. I don't want to manage the Linux I don't want to manage the kernel side of things.
Well, I think in regards of scaling, which is quite often good to mention as well, is you have actually two factors. And the first factor is that you shouldn't think of a company, you should think of a team, because in a small company you have one team. In large companies you have multiple teams, and there is a second factor. This is governance. As soon as you have governance, it's the second level, and between 2 or 3 teams, governance is oftentimes not so much the problem. But if you have let's say 10 teams, and the 10 teams are not the same, they are very different in what they do, sometimes other entities of the company, which we have quite often as well, then you have entirely different. So you have even teams which are only managing this, and you don't have that in smaller companies. And this is, I think, where we define our context. We are in the first part. So my entire content is about the first part. I am not talking about large companies. The reason for that is you can't. And one company is totally different than the next one. And in smaller companies, the nice thing about that is you could streamline it a little bit more. Of course, there are people like, hey, let's go serverless. We're only doing functions. This is an entire different story than what I'm talking about.
It has a huge architectural influence. Like, deciding to go serverless is a huge cut.
But you could compare it, right? You can compare it very well, because if you only have 5 to, let's say, up to 50 people, it is very much the same in every company out there. So the circumstances are the same, the limitations are the same, the problem cases are the same, the edge cases are the same, and you have different strategies maybe to solve that. But this is where I'm talking about, and this is very important, that cloud native in something small is different than in another one.
Yeah, but you mentioned small businesses where there's one team and no governance, and enterprises, which there's many teams and a lot of governance, right? We're reading team topologies right now in the book club. By the way, for those of you who want to join, last call is next week on Thursday. It's a free book club. Anyway, link is in my newsletter on Crafting Tech Teams. So what we need to mention is the medium businesses. The medium businesses have, and these are primarily my clients, and I see a lot of this, have more than one team, but governance is not established yet.
Exactly.
So they might have several teams, but it's not quite clear where the boundaries are. It's not quite clear, are we sharing infrastructure?
Are we managing our own infrastructure? Is some part of it managed, some part of it not managed? What happens with SOC 2? What happens? Does everybody have access to everything? When does governance start, right? And that's a really scary place to start from. And if you're going into the cloud with that level, with that scale and lack of governance, you're just made it much easier to scale all of these problems, right? And that's when I see most of the sort of naive serverless approaches go really wrong, is because then one team says, well, we tried serverless, it didn't really work for us. We didn't know how to handle a code boot problem because our architecture is optimized to running all the code all the time in one server. And another team that has 400 serverless functions and they don't have observability, and they end up racking up a huge cost to the same credit card that's running that other server, and then it goes down because it runs out of credits, right? So it's really difficult to orchestrate this move and say, oh, best cloud native is serverless, let's go to serverless, because it requires...
It is about strategy, and maybe... What we totally ignored was the topic of the title of the stream today, which was actually the game-changing aspect. So for us, it is about the strategy. Let's quickly cover that one, right? Yeah. So in our context of small to medium-sized businesses, which means medium-sized is still included, other call that scale-up. Okay, so the point is, let's do a little bit of history now for the next, let's say, 50 more minutes.
I have to go in 10 minutes. So
okay, let's take this time frame. So from a traditional aspect, you created your PHP application, your ASP.NET C# application back then, and you hosted it on some form of Apache server, Nginx server back then, or IIS web service, something, or Java even. No, there's a lot. But you needed to host it somewhere. And there were no real clouds back then. So back then you had some data center. Somewhere was a data center, or you had a rack in your office. That was like that. So, and then the clouds came. And this was where you had those virtual machines. This was where virtualization was becoming a thing. And you started to use those kind of things. Then you rented... Exactly. You rented servers for a specific amount of time, like 1, 2, 3 years, and you actually then put your payload upon that, which was actually just uploading via FTP stuff, the automated make script, something like that. Then you basically ran it there. So you competed with on-prem and VPS systems. This is what you've done back then. The problem was...
primarily shared hosting.
Exactly, but you had this constant conflict between IT ops or sysadmins or administrators and the actual developers who developing those things.
The main issue is when a hard drive breaks, somebody has to go and manage a RAID field, a RAID pool of some kind, and physically go and replace the hard drives and recable things and reconnect UTP cables and, God forbid, cut Cat6e cables manually. And the whole point about that issue was that most of the servers, the hardware, most of the time was a parking lot. It was not utilized.
Yeah. And very underutilized. So there was no over provisioning. So you had this over provisioning came later.
Exactly. And it was underutilized, so it was idle most of the time. And when you did have a spike, it was very difficult to scale up. It was very difficult to vertically scale a server and make it more powerful without downtime. So the only choice was underutilization 90% of the time and another server.
And we weren't used to something like Docker today. So we weren't able to scale within a server even. So you had one service which was just running, right? And if your server capacity was full, it was full. Period. There was no scaling like that in that mention. So scaling, it was there. Like there were even, let's say, load balancers with upstream targets back then. Even Nginx was already capable of doing that. But the problem was the applications back then were not built like that. So there were so many things in that area. And what Cloud Native, to get to the point now, Cloud Native for us as a company was the shift of mindset. So it's not about how you run your service. This is the end result. The point is how you build your software. So you build your software in a way that it's scalable, that is stateless, that is basically in every aspect flexible. It is even agnostic. This is what I'm talking about.
Stateless nature is the main one, right? So that
Yeah.
this idea that if I'm running a server that is hosting primarily the PHP compute,
Yeah.
I will not use
Not
the
a
file
session.
system. I will not use the file system for temporary storage. I will use S3 for that, or I will use
Exactly.
a managed
With-
database for it, or Redis, or I will use Mongo, or I will use
So
database.
a little example there, a good
that's-
example.
and that's exactly the same problem of utilization, because usually you'd have one server, so you would have a mailer service, you had a POP3 IMAP service on this server, you had a logging rotator on this server, you had a backup system on this server, you had a database on this server, you had PHP on this server, you had, God forbid, Java on this server, you had FFmpeg on this server because you wanted to resize images. and
Sounds
convert
like a
images.
Windows server for me. Oh,
Right? And you had
and you really relied on backups because it was so hard to recover that server alone, right?
And it was extremely difficult to manage this server because you couldn't upgrade the kernel, you couldn't upgrade the operating system, you couldn't upgrade PHP, you couldn't upgrade Java, you couldn't upgrade FFmpeg, you couldn't because everything was coupled and bundled together
Yeah.
to one artifact, and it became impossible
One
to manage.
artwork.
And it wasn't clear what the boundaries between the services were because the developers just used everything that was available. You know, they treated the one rack like a Game Boy. It has, I don't know, 640 bytes of memory, and we will use everything, even the buffer space, even the buffer overflows. We will use everything at our disposal. And that's what made containerization extremely difficult. Teams that worked like that, teams that thought like that, teams that architected systems like that, and they said, well, I want to know on what kernel I am. I want to know on what operating system I am. I want to know what version of the system I'm running.
Yeah, it is because they were used to, they need to know that in order to run and fix the systems. And this is the mindset change. This was my talk in the CloudFest was about.
this was
How to
Figma.
change
And-
this,
And
right?
this thinking of, I will just write JavaScript and run it anywhere. This kind of thinking was stigmatized, especially from the C-based crew that were used to being close to the metal. And I think, and that still has its use cases because none of the interpreted languages do compiler prediction, CPU path prediction or compiler optimization. So they will generally have a performance issue that cannot be resolved. And I wish we had, tail recursion on more languages and TypeScript, please, but it's not going to happen. But it comes down to this aspect of the cloud native transition was available as infrastructure very early on, but it was just this mindset of architects and CTOs and engineers that really prevented this adoption of, no, guys, you got to separate your concerns. You have a server that does compute. Don't store images on the disk.
For example, you mentioned that beforehand with the S3 storage. So the S3 storage was the evolution of the volume. So let's say
the
exactly.
volume.
And the problem is we had that quite often when we helped others to become cloud native, and they ask, let's go to that provider, but this provider doesn't allow volumes for Kubernetes. We cannot use that one. But this is not cloud native. So cloud native is disconnect because Kubernetes is a technology which was there before. Cloud native idea was actually there. So it is not a cloud native technology. It's just used in the cloud native space to actually use it, but you need to use it in a specific way. If you start to use Kubernetes with a volume, it is actually not scalable in that main, so especially not regional. So S3 is basically a totally separated way of storing your stuff and basically your orchestration of the compute, of the business logic, all this kind of stuff. And this is then was the evolution to the idea of having something which is another service in the cloud, which is storing the data, but it's not a connected volume to one instance of the cluster, to the second instance of the cluster, and God forbid that one of the clusters don't have a connection to the volume anymore, and all those kind of things. And this is the same for databases and stuff like that. So you try to disconnect everything, and those disconnects are actually what forces you to adopt that into your mindset. And I say mindset not because like the architecture, the way you do it. It is because the let's say the reluctant part, the hesitant part, were the human brain, the resistance to change into this new way of work. Because And that's in every cloud native transition. The first half of a year we were basically part of it was to convince the people to actually do that. It was not the technical issue. The technical issue isn't that great.
I remember we're server at Amazon, so we were heavily on Amazon. Like we were a heavy cloud adopter, and Amazon released serverless functions, and everybody was like, "I'm not using that." Everybody was architecturally, engineers, CTOs, heads of engineering. Everybody was saying, "You know what? I'm not using that. It's weird. I need to think about cold boot, warm boot, prep. Is it?" You couldn't even dedicate instances back then. It was unclear how it scales. It was unclear how it stickies. You needed to learn batching. It was a completely different paradigm of work. Plus, it forced you to use JavaScript back then. The old, I think ECMA 5 Java, ECMA 3 JavaScript. And it's just, it's just gone to the head. And it was very difficult to work in such an environment because you wanted to use frameworks or libraries and you couldn't pull them in. And it was this very counterintuitive way of saying, no, just, do domain-driven design, do event modeling, do event-driven architectures, and actually create a function. Don't take your monolith, copy out a service that requires 10 different frameworks and 40 different libraries, and put it into a serverless function. That's silly. And I think that's where this hesitation came from, as everybody was used to thinking like that.
Yeah, that was a lift and shift approach anyway.
Yes,
and I think
yes,
this is something to mention as well in the cloud native transition, is that many companies think they do a cloud native or native cloud transition, doesn't matter in this case. And what they actually do is putting their stuff into the cloud, which they already built in the traditional way. This is not cloud native. I saw even rebuilds in a pattern, in an outdated pattern, and they thought, we are using Kubernetes right now. We are cloud native. No, you are not.
Software as a service, but it's service-oriented architecture, but it's not microservices. It is a distributed monolith.
Mm-hmm.
And they say, we're cloud-based, cloud native, we're using serverless. But no, it's just a monolith that has many compute nodes and uses 2 or 3 centralized databases. That's still a distributed monolith. That still has the same problems of the old school architectural thinking, because they're not independently deployable. You can't migrate them independently, which means that the time it takes you to get to another cloud vendor scales by power law on the scale of your current system, on the amount of nodes, amount of people, amount of teams, amount of amount of data involved. Because everything is coupled to everything, just as it was on that one PHP server that had PHP, FFmpeg, Java, etc., all installed on one server. But you didn't actually solve this problem if you're using cloud as this, thingy-majig bag where you put everything just dump everything onto one VPC. So it has to be architecturally. Like
what
has to be to some degree aware of the layers it communicates with. I am building a server. It knows about this other service and that other service, and there's service discovery in between them, and I don't know about anything else. I might know about the service mesh if I'm on Kubernetes, and that's it. I don't know about other elements inside my cloud, right? So I sort of define a boundary and a black box, and the puzzle piece has a very distinct shape, and then it can only go into that shape of hole inside the cloud. And then you basically create a mesh that says, in Germany, we can have 10 of these and 20 of those, and then we scale it appropriately. And in the US, we have many of those, and those auto-scale to any size, and that's cloud native. Defining that template of shape that you can then say, this is my application, this is how it behaves, this is what kind of animal it is, and on this region, this is how it can scale. These are the scaling rules. And that is an application in on itself that is basically a platform as a service for your engineers, right? Okay. So this platform engineering aspect to your product.
What we have really missed again is still the topic. So let's get to the final thing that we actually say why it is a game changer. So why is it? Okay, I forgot. No, I didn't forget. So it's a game changer. It's a game changer because
You gotta say
it
it now,
actually is. It is not about scaling your application. So everyone is talking about, hey, if I get to the cloud, I have auto scaling great. I can scale. Actually, this is not the problem of most companies, especially in the beginning. The problem is more like how do you actually scale the application, not the users which actually uses it. It is about how do you scale the complexity of your application to agree that you actually can still handle it on some point. And cloud native, and you already mentioned that. So the idea of microservices actually is very closely connected to the cloud native, even though it is not a definition, part of the definition. But the idea of disconnected...
It is part of the definition.
Yeah, not the original one, let's say. It came later to it because everything you do in a cloud native transition, if you do it right, you will get to the point that microservices are actually the better choice for long-term projects than it is to have any form of monolithic system. And the point is that, and this is actually one of the game-changing things which was for my company, because we started, and I talk about things like substitutability, because we have many clients, we have many products, and are able to actually manage this still as an SMB. And this makes, and Cloud Native made this possible. Before we were actually Cloud Native, we were basically stuck in our own complexity in a monolithic way and called everything legacy system, but we're still working on it and not able to actually move away from the state of being or staying in legacy state. Cloud Native was the reason why we actually started to do legacy migrations, that we actually gained flexibility and agility again. And this was due to the fact that we started with containers, that we started with services, orientation, decoupling, and don't care about the actual let's say, operations anymore. So this is the reason why I'm often talk about focus on development, focus on the feature, focus on the value stream, and not how it is run. So this is one fact which I wanted to say before you disrupt me. When you because you disrupt very often. So let me quickly tell you, if you are, for example, on the floor on CloudFest or any other conference, then cloud vendors always tell you that they have a great service. The point is you need to disconnect from that. It doesn't matter. What you need to take care of is, first of all, total cost of ownership, and that any form of operations is just cost. There is nothing in benefit. So you don't earn money or not a single penny with any form of infrastructure. It's just cost. No one pays you for having infrastructure. No one on this planet does in this case. So you need in this moment to understand that Cloud Native was the answer to that as well. So Cloud Native told you to build a good application and leave the other things to the others. So you save a lot of money by not having unnecessary personnel, unnecessary fights between devs and ops. So DevOps was a part of Cloud Native. So it's very close connected to the idea of Cloud Native. DevOps outside of Cloud Native is very hard to implement. It is something which people struggle. So you need to connect those two things. And this was the actual game changer. So you actually been able to be agile as a small company again. So this was our context. It's the same, of course, for large companies. But this is the actual game changer I just wanted to say after 2 hours now. And it's extremely valuable to have that in your company, to have that type of agility early on, to understand that, and not being locked in too much and not being in the old world too much, which is my opinion why Cloud Native itself, the definition of Cloud Native, is a good one. Even with microservices. I'm a fan of microservices in small businesses. Everyone on LinkedIn says you are stupid if you use microservices. It is not.
But that's because they don't know the architecture behind it. And who was it? Daniel mentioned the Cloud Native. What's the C stand for? Computing Foundation. Right. So the CNCF. It highlights all of these things. You can't just go cloud native with your current level of understanding. And I'll keep myself short because I do have to go. Because to be truly cloud native, you gotta adopt new inversion principles. You gotta understand Vitess. Vitess is amazing, right? So it is a federation backend for managing connections to your SQL driver. Please use that, because otherwise you're still using the single host, single endpoint way of managing connections, then you'll have to have a centralized location to manage connection pools. The same way, logging will be different. So you need to adopt, you need either Jaeger or you need Prometheus or something that is an open source sort of hardened piece of software that allows you to aggregate logs, because you won't be used to aggregating logs. You'll be used to SSHing to one server or having your logs be copied, and then the logs are marked by server, and then you read the logs. And you just gotta get used to this cloud native way of working of everything you want to observe has to be aggregated, which means that the observability tools also have to be cloud native. Your way of portaling to every system needs to be cloud native. Your way of provisioning new versions of mandatory packages on your boxes, that needs to be cloud native, right? So you can't come at it from this perspective of, I used to maintain hardware on a monolith system and then make a copy of it virtualized into a Docker container and then send that somewhere. It doesn't work from that perspective, because architecturally you're not thinking about the right scale of problem. You're coming from like a large piece of metal, then you're coming down and say, okay, I have a service in here. But you have to think about it as, no, my service is actually larger and it's running on 40 different pieces of commodity hardware, and I have to be able to split the big software bit down into 2 or 3 layers so that I know how to think about it. So usually there's an inversion in routing, an inversion in telemetry, an inversion in disk storage of some kind, an inversion of package management, so you might need a local private NPM package manager. You might need a package manager for any kind of Maven or artifact repository for your Kubernetes images. You might require what else is you might require something the equivalent of Traefik, right? So some kind of sticky session management or socket session management or keep alive management that maintains some kind of state towards servers that are stateless, right? So that you know that, okay, the server doesn't know about the user, but the router knows that this user always has to go to the server without the server having to know about this. Because in a traditional system, the server would know about this. And this inversion, again, is an architectural pattern where the developer has to get out of their primary framework, out of their primary language, and the CTO has to connect different competences. They have to connect the dev with the ops and shift some responsibilities down to a more autonomous team responsibility rather than an infrastructure concern. And that's the hard part here. That's the hard part of adoption if you're coming from that traditional way of thinking.
If you, as a developer, and that was normal back then, as a developer who's supposed to create features, if you know a lot about ODBC drivers, like TLS1 or something like that, for SQL Server, then it's a sign of a very inefficient development cycle you have, because you're dealing with things which are just obstacles for you and doesn't benefit at all. So if you need to take care of those things as a developer, you actually have not understood the idea of DevOps or Cloud Native in that way, because Cloud Native does solve that. If you pick, even if it's a managed service or even a pure cloud-based database, right, a scalable one, you don't take care about those things anymore. You just use a service, an API, and it does work, right? And the only thing you think about is this API, this interface, actually fulfilling my needs. This is my concern, right? Is it actually running, right?
Is it running at the level of orchestration that makes sense to me, right? So is the management, is the aspect of being managed, is it running at the right level of abstraction? Because you might need, for example, I see this a lot with Percona users, people who use Percona's managed database services, they then end up wanting direct access to the host because they might have slow query logs, or they might want to reclaim disk space on an InnoDB table, because it does have that level of implementation details still, right? So you might actually want to sometimes be able to express yourself in a way that doesn't require you to learn a hugely complex declarative config schema. And it's possible that you missed the mark. It's possible that it made sense to the CTO, but for the DevOps team, it didn't make sense, right? That they still want direct access to the database. And I see a lot of people when they have a lot of companies where they have a large managed database and like some parts of small databases or caching systems that they self-manage inside a team because they haven't done that full organization-wide transition, right?
Yeah.
Where the governance isn't organization-wide yet, and nobody is comfortable with it because there might be a lack of coaching from within the company. There might be a lack of not supervision per se, but let's say facilitation, right? So they don't have DX. I see a lot of recruiters say, "Oh, DX, we don't do this here." There is no developer relations or developer experience or staff engineers inside that organization. But at that scale, let's say of like a medium-sized business or like a scale-up, you get these concerns where, Brian would say platform engineering concerns, where you have to go down and say, okay, well, we are solving a business problem. We have a product here.
Yeah.
And we're wasting a lot of time fixing the same problem over and over and over again. And it seems we need a custom solution to this or a better cloud provider. But we need one now. And if we can't decide, we will have to make the team autonomous to solve it for themselves. And then hopefully outsource it as a solution to the other teams. Then you create a platform team out of that, right? But that decision point of, if we don't find a quick solution to get to a different cloud because it doesn't fit our needs anymore, we will need to make the team so autonomous that they can solve it themselves however they see fit. And that can be another source of chaos where you might have governance, but then that team does whatever they want, and that's very difficult to manage.
Yeah, this is a topic for itself, because if the teams are working in entirely different business domains in your company, then it's not much of a problem. But if they actually work on the same product, like on services, often on context or bounded context of the actual domain, then it is
they
a
might
problem.
be sharing a common platform for user management or for from tenancy, let's say.
But I would say let's wrap up, right?
Let's wrap up.
Because you need to go and I need to go as well. We are a little bit over time. So Kaloyan already said that it's actually interesting. It was an interesting discussion. So was mean that he actually ended the session already, right? No. It was actually quite interesting. It is always interesting to talk about that because it is, let's say, very foundational for most people. And I had the feeling that I wasn't hearing or seeing the terminology of cloud native too much in the last month. Somehow it was more prominent in the years before. And I don't know exactly why that is, but because DevOps and cloud native are so important topics actually, and maybe we should integrate cloud native a little bit more into our sessions right now.
I think the cloud native discussions started declining on social media when there was that huge Kubernetes and the Red Hat fiasco. Like I noticed that once the artifact vendors, the artifact repositories started fucking around with who owns it and who doesn't own it and who has privileged access and is it an open source project, is it not an open source project, and is it part of Google, is it not part of Google, that I think started creating a rift, and people were looking for active alternatives for Kubernetes, even though the big
I need to go.
Standard systems recommend Kubernetes. You need to go. I need to go. Thank you.
So thank you, everyone.
Thank you all for joining us.
See you tomorrow.
Live. Tomorrow is about testing.
Let's test.
Let's test.
See you then. Can you wrap up the stream for us today?
I can wrap up the stream. Yes.
Thank you, everyone. See you tomorrow then.
Hi, Adrian.
Bye-bye.
For those of you who are still with us, thank you so much for being with us live. The comment stream was super active today. Thank you. Kaloyan is still here. No, we're behind Kaloyan. We're 2 minutes behind Kaloyan because Kaloyan is from the future. Thank you for staying with us all the way to the end. We had quite a busy stream today. So Daniel, especially, your comments were point on. Like, I really appreciate all the effort you went into sort of writing and sort of having our active conversation with us live. I wish I had checked your LinkedIn sooner. If I saw you were director of engineering at MasterCard when we were having the fintech discussions, I would have invited you on to come on as a hot joint to maybe be able to contribute live next time. Thank you so much for our live viewers. If you want to support the stream, we have a Circle SO community, which is this one. If you want to basically join up with us and be part of monthly, let's say monthly after show coffee hours, where the regulars can come and sort of chat to us off camera if you want to discuss something private. They also aren't recorded, so it's just like a little bonus. And if you want to support us, there's always our private channel. So I run Crafting Tech Teams, and Adrian runs Snackable CTO on Substack. If you have a favorite, you can pick and choose your flavor. So yeah, tomorrow is about testing. We're talking about non-TDD aspects of testing. So testing quality primarily aimed for managers, tech leads, engineers, architects who are sort of struggling with the whole pyramid of testing and when it's helpful and when it's not helpful. And you usually tomorrow basically a dedicated sort of bottom-up session about going from that style of tests to how it impacts you creating a culture of engineering excellence, you creating a culture where quality is being taken seriously, and how basically the type of tests can help you, because everybody tells you unit test a lot and end-to-end test as little as possible, and I don't think that's helpful advice. So we're shedding some light on that tomorrow. Thomas, one of our regulars, actually suggested that topic, so thank you so much, Thomas. And I have to go. I'll see you tomorrow. Thank you so much. Sorry, that was a loud noise. Yeah, some elevator music, and have a good one. Ciao.